Good morning, UP scientists. Last week we took a look at a couple different ways that substances can dissolve and how to model those at the nanoscale. Today we're going to just continue along that path and give you a couple more models of solubility. Today we're going to be making our own models so that way we can solidify that understanding of what it means for something to be soluble and how those molecules interact at the nanoscale. So first thing, we want to think back to in the classroom. What were some of the models that we used when we were talking about separating mixtures, when we were discussing chromatography? Just put those up in the answer to the right. And some of those models we'll see in 1 second. They include things like the pasta model, our fan model, and for the last couple of weeks, we've been looking at a couple models of dissolving. So if you remember, what are some of those models that we've used over the last couple of weeks? So if we take all those models and put them together in our chart of models for the chapter, we have our pasta model from the classroom. Remember, we had the 3 different sizes of pasta that represented 3 different sizes and shapes of molecules. We had our different kinds of molecules that were drawn in the Made of Matter book, which you can access using the information we're going to give you later in the lesson if you want to go back and look at that. We had our fan model. We did drawn and nanovision models of chromatography. Last week, we went into the modeling matter simulation in solubility mode to look at dissolving. And last Friday, we saw drawings of models from our book, Solving Dissolving. So based on those models, what are some of those nanoscale ideas that we've been able to show using those models? Because remember, nanoscale is something that we can't see with our eyes, or even with the most powerful microscopes, are going to have trouble seeing this kind of thing. So what are those, using those models, what are some things we've been able to show? All right, so some of the things you should have came up with there, things like attraction between molecules, which we showed in our fan model and in that solubility model last week. We've been able to show different things: mixing, dissolving, spreading out. And since models show things that are difficult to observe, scientists use them all the time to help make explanations. So we're using models to show what's happening with these molecules, right? So these models help explain what happened with sediment in our flavor ingredient test. So remember our flavor ingredients test, we tried mixing those 4 different ingredients with water and see what happened. We had the sugar and citric acid dissolve and didn't leave any sediment. And then we had our pepper and cumin that did not dissolve and did leave a sediment. So thinking back to that simulation from last week, is this particular model where it's showing molecules number 2 and 4, is this a model of a solid that has dissolved in the liquid, or isn't one of a solid that didn't dissolve in the liquid? And how do you know? Right, so this one is actually going to be a model of something that dissolved in the liquid. There's 2 different types of molecules. They're all mixed together, right? And the 2 types of molecules seem to be attracted to each other. You can tell they're attracted to each other because right here we have molecules number 2 and 4 have a high attraction between each other at the bottom. And we also see that we have the molecules sticking to each other and making these black lines around the edges to show that they're now connected. Okay, so what is this showing in a nanoscale that can help us explain what we see on an observable scale? So how does that, all that stuff that we just talked about, that we just saw, how does that help us explain what we saw when we actually dissolved that sugar or that citric acid in water? Yeah, so hopefully you got something like, right now we can see that at the nanoscale we have two kinds of different molecules that are evenly mixed or spread apart. When we're at the observable level, when we're looking at that cup of sugar or water, um, that might explain why the substances disappeared, why they aren't visible anymore. They, after stirring, maybe maybe those clusters of molecules broke up so that the individual molecule particles of sugar are so small that we can't see them anymore. So how about this one? Is this a model of a solid that dissolved in a liquid, or is it one that didn't dissolve in a liquid? And how do you know that one? So similar to the one we had before, this is a solid that has dissolved in a liquid, and we know that because there are two types of molecules that are attracted to each other. So the sugar molecules here are attracted to the water molecules. And so how is this one similar to the model we just looked at, and how is it different? So what you should have gotten here is something like, both of them are representing molecules with symbols. They both have different symbols for different substances. So here we have the triangles are the water molecules, the hexagons are the sugar molecules. In our previous model, we had, it didn't specify what was what, but we could say something like, okay, so the green 4s are the water molecules and the orange 2s are the sugar molecules. Another thing that something that was different was they both used different shapes to represent those different molecules, right? So just like we just looked at, they both use shapes, but they use different shapes. And similar to the other question we had for the first model, what is this one showing at the nanoscale that helps us explain what we see at the observable scale? So what does this model right here show that happens to individual molecules that helps us explain something that's going on at the level that we can actually see with our eyes when we mix that sugar into the cup of water? Last activity we're going to do today is we're going to make our own digital models of what dissolving looks like, and going to be something similar to the ones we just saw. So as we saw in our solving dissolving book, we need to use both words and images to explain dissolving. So we're going to create some digital nanovision models of dissolving right now. So we're going to create two different models, one in which the solid is soluble in water and the other where it's not soluble in water. For each different model, we're going to choose one shape to represent water and just one other shape to represent one other ingredient listed in the key. So you're not putting all 5 things in one model, because in our real experiment, we only put 2 things in the cup at the same time. It was either water and sugar, water and citric acid. We didn't put water and sugar and citric acid and cumin all in the same cup. So once we choose those 2 shapes, we're going to drag them over into the key. And then you're going to drag lots and lots of water molecules and lots of the other molecules that we picked into the mixture in a cup box. And we're going to arrange them in a way that's going to show what happens. So to get to this, you want to use your 5th grade science bookmark, or just simply go to this website here. You can type this in, apps.learning.amplify.com/elementary. And I will demonstrate that over here. So we're going to go apps.learning.amplify.com/elementary. And we're going to log in using this username and this password, since it gives us access to everything. So we're going to go log in with Amplify. We're going to do remote learning at tryamplify.net and remote learning 2020 for our password. Okay, so then next thing I want to do is step 2, scroll all the way down and click Modeling Matter. And step 3, we're going to click the blue number 2 to access our models. So here's Modeling Matter all the way at the bottom, blue number 2, Dissolving Model. And here's what we're going to do. So let's say you don't need to use this exact thing for whatever molecules you're going to show, but let's say I want to show this was my water molecule. I could put that there. And for whatever reason, I want to use the blue star as my sugar molecule. Then I can show in the cup what was happening by dragging a bunch of these and arranging them in a way that makes sense. Obviously, this does not make sense for something dissolved, but just to give you a general idea. And if you messed up, put something there that you didn't want to do, you can just hit undo. If you want to reset the whole thing, you can hit the reset button. So once you're done with that, what you want to do is, after you've created each of your models, the first one is going to be one that's soluble in water. The second one is where the solid's not soluble in water. I want you to take a screenshot of each of those. And the way you do that is by holding down the control button and the shift button at the same time on your Chromebook, and then pressing this button right here, the one that's for switching windows normally. So you're holding control shift and you're pressing that button. That'll come up with something on your screen that lets you, something that looks kind of like this. Let's see if it'll work on mine since I'm not on a Chromebook right now. Okay, never mind. So, but anyway, it'll come up with a little box that you can drag across your screen, and you just want to drag it over the part of the screen that includes your model here. So you just want to include basically from the top left here all the way down to here. Once you've dragged that box, it'll pop up with a little window in the bottom right that'll say it's been copied to your clipboard. And you want to go into the Google Doc that's attached to today's assignment. There will be 2 boxes there. One of them will say model of substances that dissolved in water. The other will say model of substances that did not dissolve in water. You're going to just go to whatever box that is and hold down the control button and then press V to paste that screenshot you just took. Once you've done that for your first one, you can go on to the model of your second one. And remember, we want the second model to be something that's not soluble in water. So to finish up today, we just got a couple questions left. After you finish, so you should have finished those models by now. And what happens, so we're going back to our investigation question. What happens to the molecules of a solid and the molecules of a liquid when you mix them together? You should have a much better understanding of this right now and be able to give me a pretty solid answer in the box over to your right. So here's what you should have gotten as part of that response, right? So our first key concept for this lesson is that when molecules of a solid are attracted to the molecules of a liquid, they spread apart and mix together evenly. This is also what we call dissolving. And then when the molecules of a solid aren't attracted to the molecules of a liquid, they stay clustered together as a solid. And in this case, they would not dissolve. So we're just gonna go ahead and to wrap up the lesson, we're gonna add that digital nanovision model of dissolving to the chart we've got going. I'll put a link to this chart in the assignment on Google Classroom. And then have one more question to end today's lesson. If we weighed a cup of water and a spoonful of pepper separately and stirred the pepper into the water and weighed the mixture, how do we think those 2 weights would compare? And why do you think that? So this is just to get you thinking ahead of tomorrow's lesson. So we have a cup of water, we have a cup of pepper. We're gonna weigh them separately. Then we're gonna stir them together and weigh the mixture. How do you think those weights would compare? Do you think the mixture would weigh more than when we weighed them separately? Do we think it would weigh the same? Do we think it would weigh less? Why do you think that? And same thing for sugar. So the pepper didn't dissolve, the sugar did. What do you think would happen to the sugar if we weighed them separately, mix it together, weighed it together? So as soon as you're done with that, you're done with your lesson for today. and I will see you all tomorrow, where we're going to be writing scientific explanations of solubility. So have a good day, and I will see everybody in the Zoom room or tomorrow. Bye.